Okay, here's our video on the converse of the Pythagorean theorem. Some people say converse, but most mathematicians say converse. And we're not talking about the sneakers, the old school Dr. J Converse sneakers. No, not the sneakers, but a mathematical term. And it's pretty simple. It basically states that with the converse, if a squared plus b squared equals c squared, then you have a right triangle. And if a squared plus b squared does not equal c squared, then you don't have one. That's all it is. That's what the converse means. So the word converse, the reason why they use it in math, it just means the reverse. So here's the definition we can read again to make sure we know it. The converse of the theorem, Pythagorean theorem, again, if a squared plus b squared equals c squared, then you have a right angled triangle. That's what you have. And the right angle is directly opposite the hypotenuse. Right, so again, here's the hypotenuse, there's the right angle, directly opposite, which we talked about in previous videos. And we also talked about this in previous videos. So if I had a right triangle, and if that was 3 and that was 4, we know it's 5, the basic 3, 4, 5. If this length somehow was 6, we know that's not a right triangle. The converse will tell us, because 9 squared, 9 plus 16, because 3 squared plus 4 squared equals 25. And the square root of 25 is not 6, it's 5. So that's basically what the converse is saying. And later in the year, we'll also talk about converse. There's a logical term when we talk about logic, and that's much later in the year. So again, converse means the reverse. So in logic, if I say if it is raining, the dogs bark. The converse of that, do you know what the converse would be? If the dogs bark, it is raining. You just switch it around. That's what converse means. But we'll deal with that in other videos much later in the year when we talk about logic. Okay, so now there's more to this converse. So what we're saying is this. I'll erase this. Let's bring it over here. So if a squared plus b squared equals c squared, then we know that the triangle is a right triangle. So it's a right triangle. Don't forget the 90-degree box. But if a squared plus b squared is greater than c squared, then the triangle will be acute. Put an acute triangle. And then there's one more. If a squared plus b squared is less than c squared, the triangle will be obtuse. So just put that there for a minute so you see it. So again, if a squared plus b squared equals c squared, we have a right triangle. If a squared plus b squared is greater than c squared, we have an acute triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. And we should know our obtuse and acute from 7th grade. So just to review, we know an acute triangle, and we have an obtuse triangle has a 180-degree angle to it. We know a right triangle has a 90-degree angle, an obtuse triangle has a 180-degree angle, and there's no angles greater than 90 degrees in an acute triangle. Okay, so let's look at one here. Okay, so we'll label the legs A, B, and C. So we have, again, a squared plus b squared, and we won't say equals yet. We'll just determine what this is. So we have 3.5 squared plus 4.5 squared, and then we have 6 squared. So figure this out, and let's see what type of triangle we have. Well, obviously, just looking at it, you know that this is not a right triangle. You do have an angle that's 180 degrees, so you know this is obtuse. And if you remember the rules of an obtuse triangle, if a squared and b squared is less than c squared, if it's less than c squared, you're going to have an obtuse triangle. So this has to be less. So let's check. Okay, so 3.5 squared, that's 12.25. And 4.5 squared is 20.25. And we know that 6 squared is 36. We know it's obtuse, so it has to be less. This has to be less than that. If you add all this together, you get 32.5, and you know 32.5 is less. Right? So using the converse, we can see with our obtuse triangle that this is not a right triangle. It's an obtuse triangle. And we didn't really have to go so far because we know we have an obtuse triangle. And so you know that the longest side is going to be more. Okay, so let me make another triangle here. Well, let's make it something like this. Something like that. Let's say that was 8. That was 8, and that was 3. So what do you think this is? So again, we can say that's A, and that's B, and that's C. So again, we have 3 squared plus 8 squared, and we won't put an equal, we won't put anything there, and we'll say an 8 squared. So what else? So we have 9 plus 64, and here we have 64. So we know 9 plus 64 is greater than 64, and as we said, if these two are greater than c squared, we have an acute triangle. And we know in an acute triangle we have nothing greater than 90 degrees. So just remember the rules. If we have a triangle where a squared plus b squared equals c squared, we know it's right. If a squared plus b squared is less than c squared, well, we know that's obtuse. And if a squared plus b squared is greater than c squared, we know that's acute, just like we did here. So the converse, again, it just means the reverse. It just means that if a squared plus b squared equals c squared, then it's a right triangle. And if it doesn't come out that way, it's not. So, is this a right triangle? Now, there is no right triangle box, but let's say that we had this on a test. So what would you do? 5 squared plus 6 squared, does it equal 7 squared? If it does not, then it's not a right triangle. So we have 25 plus 36. Does it equal 49? No, this is not a right triangle. Now there's another theorem we need to talk about. It's called the triangle inequality theorem. And we went over this actually in 7th grade, and in 6th grade we talked about it. We just didn't call it this. The triangle inequality theorem, it's very simple. All it says is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let me write over here. So if I had a triangle, any triangle, let's say, and I said that was 3 and that was 4, these two sides have to be greater than that side. 4 plus 3 is 7. They are. The sum of any two lengths. Let's take these two. 5 plus 3 is 8, greater than 4. 5 plus 4 is 9, greater than 3. So any two lengths has to be greater than the other side. So if you had something like this, if this said 5 and this said 4, this can't be 10. Why? Because 5 plus 4 is 9, it has to be greater than that. So this, you wouldn't be able to make a triangle. This would not be a triangle. That's what the triangle inequality theorem states. So let's just do one more. Tell me, is this a can we make a triangle out of this? Can we make a triangle out of this? So just draw a basic triangle, doesn't matter what it is. We have one that's 5, one that's 4, and 5.6. So is this a triangle? Can we make a triangle out of this? 5 plus 4 is 9. 9 is greater than 5.6. Checks off. This side checks off so far. 5.6 plus 4 is greater than 5. 4 and 5.6 is greater than 5. This is a triangle. So each two sides have to be greater than another. Okay, so that's the triangle inequality theorem, and we also did the converse. Great job.